Hello everyone, this is Group 6. Today we will talk about the topic of determinants of probability of defaulting credit card. The presentation is divided into 4 parts: introduction, regression, decision tree, and conclusion. Let's look at the first part, introduction. Nowadays, for customers, credit card spending has become an important part of daily life. However, the problem of bad credit card behavior is becoming more and more obvious and serious. Therefore, it's an important challenge for ensuing banks to find a credit card defaulter previously. In this presentation, the potential factor related to default will be found by means of regression and decision tree.
These are the data we are using. There are totally 25 variables, and the first one is giving credit, and the second one is female, which is a binary variable, and these 3 imply education, and married age, and history of past payment. For example, how much month they have delayed in that particular month, and then amount of bill statement, and amount of previous payment. Hello everyone! After knowing the importance of credit card default, now we can build some regression models to analyze. There are 2 main ways to run regressions. First is linear probability model, and the second one is logit model, because there is a serious drawback of LPM that it may get predictions outside 0 and 1 that actually make no sense, so we only use logit model in our video. And we basically build 3 models, and in model 1, we include all variables using the given data, and we can see the direction of coefficients to see different effects. For example, female is negative, means women are less likely to default credit cards than male competitors, and for age, is positive, means older people actually more likely to default. That's unexpected. And for pay 1 to pay 6, they are all positive, means the more months they delay, the more likely they will default in the end. That's the same as our common sense. And for the significance, we can look at this, and we can see some of them are insignificant. That may be because those parameters are highly correlated. And we can also see the ASC of the model 1. And for model 2, we will exclude all insignificant variables to see the difference. Here is our model 2. As we can see, all parameters are significant, and the ASC increased a little bit. And what if we exclude some very important variables like pay 1, pay 2, and pay 3? Now we come to model 3. As we can see, ASC increased dramatically. That means this model is not a good model. And now we can look at the accuracy of these 3 models. The accuracy of model 1 and 2 is about 81%, and the accuracy of model 3 is about 78%. If we look at the detail, this number is very important, and this number is not as important as this, because this number means the company will lose money, and this number, they just lose some potential clients, not a big deal. And if you look at the accuracy of model 3, we can see it never predicts yes. So this accuracy is meaningless, even it's 78%, but it doesn't mean anything. And this model is very useless. And we compare the overall model. As we can see, as we mentioned before, model 3 is a very poor model. And model 1 and model 2, even model 1 have larger adjusted square and lower ASC, but it doesn't make model 1 a better model, because model 1 may face may face overfitting problems. We can use lassos to check it later in future study. Now we can move to the next part.
So hello everyone. And my part is decision tree. In this section, our goal is to find the desired characteristic to map the decision tree in this set of data with many variables. Our question is that section is what are the defining characteristic of whether a user default on a loan. In the model 1, we input all the data from variable important. We can see the P1 is equal 86, which is significantly larger than the other variable. So we can draw the decision tree with it as a decisive features. Therefore, P1 is a feature for us to judge whether a use default on a loan. If P1 is less than 2 and we choose the end not number 2, the user will not default on the loan 83% on the time. And in last, we can see the model 2. We removed the variable of par, and we want to know whether the use delinquency was necessary related to the user age, gender, or education level. The obvious answer is no, and it's hard to even find patterns in these variables. And finally, we can see the model 3. We want to know what there are variables that can be used as a feature in the remaining variable after removed the feature P1. In variable importance, we can clearly observe the difference between P2 and P3. That means that P2 and P3 can be used deserved characteristic, and then we can get decision tree in the model 3. This is the model 3's decision trees. This is all in this part.
Let's draw the conclusion. First, we learned the serious situation for credit card default and relevant data. From regression, we can get the results that Model 2 is a relatively best model, and for each parameter, P1 is most important, so they should pay attention to cleanse past monthly payment records. As for decision tree, P1 plays a decisive role in whether the default will be occurred. If P1 is greater than 2, then it will default. By contrast, if P1 is less than 2, then it won't. This is our reference list. That's the end of our presentation. For more information, please look at our detailed report. Thank you for listening.